Skunk spray is composed of functional groups called thiols and thioacetates. A thiol is an organosulfur compound that contains a carbon-bonded sulfhydryl group, shown in blue. Notice how the sulfur has two lone pairs. The backup of skunk spray consists of thioacetates. These are also groupings of carbon and hydrogen that emit less of an odor at first than thiols. Shown is an example of a typical thioacetate. Circled in blue is the functional group of a thioacetate. The main component of skunk spray is E2-butene-1-thiol. This compound makes up roughly 38 to 44% of the total skunk spray. The second main component of skunk spray is 3-methyl-1-butane-thiol. This compound makes up 18 to 26% of skunk spray. These two compounds are chains of carbon and hydrogen with the sulfur-hydrogen-thiol group attached to the one end, shown in blue. This functional group on both compounds emits the unwanted odor. Se2-butyl thioacetate is the thioacetate that makes up 12 to 18% of skunk spray. This organosulfur compound is a colorless liquid with a thiol-like odor. The main difference between this thioacetate and common thiols is the double-bonded oxygen to the carbon adjacent to the sulfur, shown by the arrow. These thioacetates are known to be easily trapped within animal fur and can cause the odor to linger, especially on damp days.
It's a common belief that water can be used to wash away skunk's odor spray. This method is ineffective due to the process of water hydrolysis. When water molecules interact with thiols and thioacetates, their functional groups are rearranged into more potent configurations. Through this water hydrolysis, the hydrogen from the water molecule attaches to the free lone pair of the sulfur atom once the acetate group is removed. Through this reaction, a more potent thiol compound is produced along with various side products. Note that there are differences within skunk sprays depending on the type of skunk. This reaction may not occur in some species. Tomato juice's main compound is called lycopene. This is a bright red carotene and carotenoid pigment found in most red fruits and vegetables. Tomato juice contains no reactive compounds to change the form of the thiols and thioacetates. Tomato juice essentially only masks the odor of the skunk smell. In order to truly reverse the smell of skunk spray, the functional groups of the thiols and thioacetates must be changed. For this change to occur, it is necessary to oxidize the thiols into sulfonic acids. The most effective way to eliminate the skunk smell is by using two common household items, baking soda and hydrogen peroxide.
These are both considered strong oxidizing agents because their chemical formulas allow them to easily donate oxygens to available thiols in skunk spray, which changes their configurations. An oxidation-reduction reaction is a type of chemical reaction that involves a transfer of electrons between two species. A reducing agent oxidizes a species through the loss of electrons. On the other hand, an oxidizing agent reduces a species through the addition of electrons. In the oxidation of thiols, two hydrogen atoms are removed, which creates hydrogen gas. This process is done with a mild oxidizing agent, shown above the arrow. The product is a disulfide that does not give off any odor.
So next time you encounter one of our furry friends, make sure you have baking soda and hydrogen peroxide handy.